All right. So we want to take this and we want to take all the information we can to talk about how it graphs. So first off, we're going to do x of the -5 on the inside. When it's inside the square root or cube root or whatever function, it's going to be the opposite. So instead of going left 5, what else is it going to go? Or where is it going to go? Right 5. So we first, yes, +5. That would also explain the domain. But first, let's talk about all the transformations, then the graph, then the domain. Then this number out here is going to be your up and down or your vertical shift, which is up 1. So up 1. Now this number here, there's 2 parts to this number. The first part, if it's negative or positive. If it's negative, that just means it's going to flip. The second part of the number over here is the actual value of the number. So I don't want the negative or positive. I just want the number here. This is a 4. So compared to 1, 4 is bigger than 1. So we're going to be stretching it because we're timesing it by 4. It's going to get 4 times bigger. So in this case, it's a stretch by 4. No, less than the absolute value of 1. The number 4 is bigger than the number 1. No, you could have a half or a decimal. A half would be smaller than 1. All right. And then how did I get 4? You're asking? I got 4. This number's 4. That's in the front. It's like if I had an equation and then I times everything by 4. Would your number equation get bigger or smaller? Bigger. If I had an equation and I multiply everything by a half, would it get bigger or smaller? Smaller. That's the idea. I'm going to keep going forward, okay? So I'm going to do 18, 19, 20. Actually, you know what? Oh, I forgot to finish the job, though. What's up? Okay. Let's finish. So we're going to go right 5. You're going to go up 1. You're going to put your dot at 5, 1, because you went right 5, up 1. Instead of being upwards, we vertically flipped. So we're going to be downwards. The stretch part. Yeah, that's fine. So in this case, it's going to be upside down. When it comes to the vertical stretch part, do not worry about that in terms of graphing. It's okay if you're like, oh, is this a graph? You have to show a graph. I asked for the transformations, the graph, and now let's talk about the domain and range. Yeah, I know. That's why I only get 6 problems. So this one, the domain is going to be x is greater than or equal to what? Not 4. In this case, 5. So look, you start at 5 and you keep going this way. So that means all your x values is going to be 5 or bigger. Y and 1, but it's going to be less than or equal to. And you want to think about it. This is height 1, right? This is the height at 1. Look at where your equation is. It's underneath that. So you want to say y is smaller than 1. This is number 82. Any question on this one, or can I move to the next one? I'm just going to finish the 21. Let me see. 19 will teach you the same thing with 17, okay? What are you going to do 19? But 17 and 19 has the same lesson you're going to learn, okay?
Wait, what is 19?
What are you asking? Yeah.
Three-fourths cube, but once I saw the fraction coach, I had.
Okay, don't be scared of the fraction.
It's actually very.
Okay, you need to remember this is from the first section of this chapter. What does a fraction exponent mean?
Oh, it means the third.
It means it's going to be to the 3rd root.
Yeah.
So I'm going to rewrite this before you even start. You're going to rewrite this 3/4 to the third x minus 1.
If it's 3/1.
It would just be normal 3, no? That'd be x to the third power, right? So you're going to rewrite it and look like this. I'm going to do this again, okay? So this is a cube root 1. So this is useful because it also teaches the cube root 1. Let's do all three things. First, let me identify everything that happens. Definitely, I see a down 1. There is no negative, so it's just positive, which means it doesn't flip. It stays normal. What? Shayna, you gotta say something? There's no flipping. There's no flipping. Anything else we know? Now we have a 3/4. Now we're stretching 3/4, or AKA 75%. Is that an actual stretch? Like, do I stretch bigger than 1 if it's at 75%? No, so I'm going to be shrinking. We're going to say shrink. We shrink by a power of a factor of 3/4. Shrink, yeah, because you're crushing it. You're only 3/4 the height. No, negative would flip. Oh, if it was just negative, like a -1, it would be just a flip. Yeah, let's graph. So we're going to go down 1, but that's the only thing we need to do. No left or right. Cube root, you need to remember, looks like this. And the backside. So this is a positive cube root looking one. Again, the shrink or stretch, you do not need to worry about graphing. You don't have to worry about the stretch or shrink part of the graphing. Yeah. Yeah. Yeah, I haven't made your test, but I probably will make one question says, hey, tell me what's the transformation. Second question would be, hey, tell me how does this look from the graph. Third question would be, what's the domain and range? And I'll probably have a fourth version question where it requires you to do all three. So for the cube root, it's really easy. No matter how much I shift it left or right, up or down, it's going to be all reals and all reals. Because it will hit every x eventually, and it will hit every y eventually. And then 17 is the same thing. You just turn it into a square root that half power. And then you do the same thing you did for 18, okay? +8, yeah. And make sure that +1 is inside the square root because it was inside the parenthesis. You see that? I feel like I covered enough. Do you guys really need one more? Or? Let me see. Creepy. Let me see what's my plan. Sorry. Wait, our test is the 5th, so right? If there's no A, you just don't write anything for it. If there's no A, you just don't write anything for it. If it's just square root of, there's no A. Yeah, there's no A value. It doesn't change at all. It doesn't shrink. It doesn't stretch. It doesn't flip. So you don't have to mention anything about it in that sense. So you good? All right. I'm going to do 3.6. You know, like solve radical equation. Solve radical equations, okay? This one might be the most straightforward one because this is straight like solving equation stuff. I got it. I just want to pull up my book. Solve radical equations. That was the name. 3.6. Just want to see what they want me to cover with you. Square roots, cube roots, no duh. Anything else? Solve a refraction. Stringy solution. Oh, this is weird. Okay. All right. All right. For this one, the square root of x is 3. Now you can mental math it. What number could I plug into the square root to get 3? 9. You can mental math it. You know the square root of 9 should be 3.
Isn't it supposed to just square 3?
Exactly. So the algebraic expression is just simply square both sides. You would cross out the square root, and then it would be x equals 9 because 3 squared is 9. Wonderful. You guys can mental math that. What about this one? I just want to make sure you guys know it is actually 9, so you can believe me. Sometimes I just tell you, and then you just like, I felt that. Now, how's this? Good. If you have a cube root, you have to cube it to get rid of the cube root.
Two equal 6. I think it's 6.
Not 6.
No, it's cube root x squared. If x has to be x squared, let's say 3.
Oh, wait, let me pick a number now. I realize I want to be a clean number. Let's do 4. There you go.
I got it.
Oh wait, isn't that that thing where it's like the square root of like x cubed, the x to the third? Like, yeah, it's weird.
This one's not 6.
Well, first you make it into the thing, then work, right?
You could definitely rewrite it like that, but I'm going to show you it's easier to do the way I'm going to do it. 2? No.
Oh, wait, for solving x, are you figuring out like what times the x and the third is giving you that?
So some of you guys are mentioning,
It's
you could technically rewrite it like this. Cube root of x squared should give you 4. Now, I'm not expecting you to mental math all these problems. So I'm going to show you how you do it algebraically. I need to multiply to get rid of this exponent. I want this exponent to disappear, aka become 1. So how can I make 2/3 into 1? What would I multiply 2/3 with?
times by 3 over
What's up?
2. Times by 3 over 2.
3 over 2. So I have to multiply by its what? Reciprocal. Not multiply, I'm sorry. I have to raise the power by the reciprocal. So in this case, I'm going to reciprocate it 3 over 2.
So then
You could plug in your calculator. In this one, though, I made it so you could do it by hand. I can rewrite 4 to the power of 3 over 2 as the square root of 4 to the third power. What's the square root of 4 first? 2 to the third power, which is 8 in this case. You did the third power first, which you could square root to 8. Sam, what you did? You ready? You just did the third power first. So you did square root of 64. But what's the square root of 64, Sam? 8. So it doesn't matter which order you do it. Usually you want to do the square root first because it keeps your number smaller, easier in your head. Again, also, you literally could type into your calculator 4, you click this caret button,
Well, if it doesn't come out even.
3 divided by 2. What's up?
Well, if it doesn't come out even.
You would just leave it as this fraction part. So that's the basic concept. To get rid of the fractional or the roots, you got to do it by their opposites. Seems like the same concept as all our other functions. Now, it's not just only going to be x, you can have a whole equation. So let's say the square root of x plus 1 equals 4.
the square root of 4.
So it's 1. No. 16. So 15 is that.
Good, good. We should be 15 as the final answer. How do we do it mathematically though? We're going to multiply both sides, or we're going to raise the power by both sides of 2. we want to cancel out completely the square root.
So it's x plus one equals four. Wait,
No, what's 4 squared?
I'm sorry, equals 16
Yeah,
minus one.
minus one, which is 15. Good. Definitely something you can mental math, but I just want to show you the actual math. Now, let's talk about this. Let's do this.
Give us a domain.
Not in this section. No. It's just in terms of you're just doing math, right? The other ones is like graphing, and people don't like that. This is just straight algebra. Yeah. I'm crazy, that's why. No, I don't know what to tell you. All right, not 75.
That's
You
fine.
do that, right?
15. You know,
Okay.
You divide by 3 on both sides.
good. Before you could square both sides, you need to get the square root by itself.
24, got it.
So it's going to be divided by 3 on both sides. X plus 1 equals 5. Then you square both sides. X plus 1 equals 25. Minus 1 on both sides. X equals 24. Seems pretty straightforward, no? So anything on the outside of the square root, you gotta move out of the way first. Or any fractional exponent. Let's try this one. 10 to times x to the 3 halves equals 80. Not yet. You have to.
First you got by 10.
Yes, this is 10 times that. If it looked like this, you would do the 2/3 first, but not in this case. You're gonna do 10 divided by 10 first, divided by 10 first. Well, yeah, actually. X 3 halves equals 8. Now I'm gonna do the inverted exponent. So there's gonna be 2/3. 2/3.
Wait, how do you? Yeah.
X equals 8 and 2/3. Again, you're free to put this in your calculator, but the cube root of 8 to the second, the cube root of 8 is 2 to the second, which is 4. Again, you could plug this into your calculator, that's totally fine.
Wait, I guess it's different. Look, it is.
You divide by 10 first? Eight, 15, 21. You times it by 3. You didn't cube root it. 8 times 3 is 24. You're supposed to do the cube root of 8.
Oh,
What's up? Let's not do wishful thinking, you know. Let's keep it real. It always gets a little harder, don't it? So we did the fraction exponents, we did basic roots. What are we gonna do now? This one, x plus 1. Okay. This one's a interesting one.
What?
This is an interesting one.
I don't know.
What are you gonna do?
Yeah, do it. Oh, you want to say?
Yeah, man.
Basically, square root both sides.
Square root.
To make it x squared plus 1, you square both sides. Cancel out the 7x.
Good. I'm gonna square both sides.
Then you're gonna have x plus 1, and parentheses squared equals 7x plus 15.
I agree with that.
And then you're gonna distribute.
You cannot distribute a power when there's a plus or minus sign. So what can we do instead?
yeah.
Oh, yeah.
You don't factor the other F word. Foil.
Oh, yeah. Foil.
Foil.
What's in the other?
So you're gonna have to foil. I'm gonna do it quickly though. X squared plus 2x plus 1. So when you have, remember, if you have an exponent over a what we call polynomials. So there's multiple terms. You cannot distribute it. You have to FOIL it out. So far, yeah.
I hate you.
Sam, take that back.
Sorry. my bad.
It's okay. All right, now we're gonna subtract now we have an x squared and an x. So we're kind of, we can't actually just solve it like a normal where we get x by itself. So we're gonna have to move it around so we can set it equal to 0, so we can eventually factor. So we're gonna subtract 7x on both sides. As I do that, I'm also gonna subtract 15 on both sides. I'll just do it all in one shot. Negative 5x minus 14 equals 0. Now what do we do? You can say it now, Sam. Factor. So things that multiply to negative 14 that add to negative 5, negative 7 and 2. X minus 7, x plus 2.
Equals 0, then it's x equals -2, x equals 12.
Exactly. You got to split it. So you got to get x minus 7 equals 0. So that means you have a positive 7. And x plus 2 equals 0. So you have a negative 2. Now, Jacob, do you think it gets any harder than that? Do I think it could? Yeah, because we're not done. We have to do one last thing with this. Yeah, you know it. There's only one last thing we need to do. We need to check for something called extraneous solutions.
I think they have questions on Zoom. Getting a Google text.
No? Extraneous solutions.
I don't know if we do that.
No, and you can't just put that
Yeah.
Someone's asked them to speak.
So extraneous solutions. All right, tell them to type in the chat so I can see it. Extraneous solutions. So in this case, extraneous solutions, we need to check for something. We're evolving an equation with a square root. So we need to check if what could not be in the square root? A negative. We cannot have a negative in the square root. We need to check if these answers causes a negative inside the square root. So what you're going to do is only look at your square root part and see when I plug in these answers, do I get a negative?
Okay, so square root of 7 times 7 is 16.
So what you're going to do is you're plugging in the two answers you found, in this case, 7 and negative 2. And then we're going to plug it in and see if it causes a negative. Yeah, this is square root of 64. Remember, we don't even care what the actual number is. We just care if it's positive. This is positive. You could tell here is going to be positive. There's no subtraction. But the second one,
That is going to be no.
Oh, it's equal to.
plus 15. Wait a second.
That's a fun. We're good.
Oh, yeah, we're good.
What would happen if it was?
If it happened, it was not, you're supposed to cross this out. It doesn't count as an answer. I thought it would do that. I thought it did it correctly. Well, I'll check it out later. I'll post some homework.
You have to
It-
make 15.
No homework. This makes no sense.
You got it.
We're all sure.
No.
I will not be doing it.
Well, wait, I don't understand why we're doing this extraneous solution thing.
We have to check if the number we plug in here might cause a negative. Both times it didn't, so it's okay. I'll next time do a question where it does, so. it should
Okay.
let us.
Okay, thank you.
Peace, everyone.
You copied all the boards?
Oh.
But you still copied the boards. Oh, yeah, I like this.
I'm just trying to think, who else was here? Nessa was here?
I like that.
Shane was here? Okay.
I love that.
What up? Your farts? Farts.
and the covers that make them all different port Simpsons.
Oh, okay.
Yeah, so you look like a Spanish.
I see. I like that.
Look.
Super hot, my rap playlist.
Yeah.
Lock
Yeah,
in
my-
is like
My rap.
like my,
Workout,
like,
yeah, workout.
party. Oh,
Ish, yeah.
Look at my gym
Yeah.
playlist.
look at my bonfire.
Look at my Hebrew playlist.
Mhm.
Look how nice the bonfire.
Hebrew
is.
player?
Come on, the keeper, come on.
I see he's a Jewish
Is it
sub
Drake?
You got every type. It's just Drake.
Yeah.
Say you're on How much they are? I don't think they showed up. What do you want to? That's what you should have to Diane. Pretty sure I'm out. See you around, man. You feel okay? I saw your head was down. All right, get some rest, okay? Yeah, I think she was out. Angela, she was out. Priscilla was out. Priscilla was out. David was here. Jonathan was here.
It's funny, you gave my test.
Oh, no.
That's the definition of lightweight. I would love to get my.
I need to take this test.
I'll be like disappointed if I didn't.
No, not yet, might
I
not.
got a negative test.
So many people didn't take their test. Yeah, I
No,
couldn't.
no, no, I don't need to say
No.
that. It's my grade.
My
No, I don't have it
test-
yet.
My piece, I said, not the answer.
I
You
know.
have
Yeah.
a test?
It's crazy.
No, Sally.
Like, I could
Not enough people took the test.
You
Okay.
literally told me.
I do
I know, I
not,
was
yeah,
wrong.
I could, it's just such an easy
Oh my god,
grade.
this is
It's
home.
such a
I'm
quick
gonna,
grade.
I'm
It's
gonna
like,
cry.
You literally
Okay,
put 5 questions on the whole test.
Yo, this is what's up. When everyone says a test is
And
hard, I do well, but now everyone says it's easy. Now I'm gonna do bad.
I mean, I could have done that. I just thought like I'll be annoyed.
The test is lightweight. I think my review sheet was really good, except for the one question I forgot to put on. But
You just didn't put any of this.
what? You can't talk about it.
You taking it off. What's the difference?
Yeah, sure.
Wait, what question?
It was like parent
That's a good
function,
point.
but You took it off. You didn't know how to. I didn't know how to.
Parent function?
It's not on the
Did
test.
you grade
Is it on
any
my
of the
test?
tests?
It's not gonna be
No,
on
I
my
didn't
test,
grade the
right?
test.
I
I didn't
didn't
even.
have to
I
look
didn't even
at it.
crack it
You
open.
could just tell me if I got 100.
It's not gonna be on
I
my
didn't
test.
crack. I didn't even crack
You
it
could literally
open.
grade it right now in 30 seconds of my test. I think.
Probably, but I can't right now. I don't want to.
Mr. Toll, we took the parent
Well, you
function.
can.
I guess I could, but I don't
You
want
gotta take
to.
it off, but you don't have to.
Mr. Tobal,
Yeah, I'm
You also
hard.
don't need to
I'm
do
sorry.
graphing, I'm good.
Mr. Tobal,
How
Yeah.
sassy was my
did you
comment?
grade our tests?